In this video lecture, we shall see about testing hypothesis on the variance, that is also known as chi-square test. Here we wish to test the hypothesis that a variance of a normal population sigma square equal to a specified value, say sigma naught square, or equivalently we want to test sigma square is equal to sigma naught square, or even this test can be on the standard deviation, that is sigma is equal to sigma naught. So in this case, we usually go with the null hypothesis as sigma square is equal to sigma naught square, and the test statistic here we calculate it as chi naught square is equal to n minus 1 into s square by sigma naught square. Here n is the sample size, sigma naught square is the population variance, and s square is the sample variance. For alpha level of significance, we can have three possible cases of alternate hypothesis. First case we have is sigma square not equal to sigma naught square. Here, as sigma square not equal to sigma naught square, the both cases of sigma less than sigma naught square, sigma greater than sigma naught square will be a possible rejection for null hypothesis. So that means here, if we consider the graph for chi-square distribution, in the chi-square distribution, the entire area for a corresponding alpha level of significance will be divided into two parts. Right side we will have an area of alpha by 2, and left side we will have a area of alpha by 2. It means there will be two tails of rejection. We call it as a two-tailed test. And in the critical region, we have the region corresponding to chi naught greater than chi square alpha by 2 comma n minus 1. That is, the right side area here is alpha by 2, and in the left side region the corresponding chi square value is chi square 1 minus alpha by 2 comma n minus 1. Here we call n minus 1 is the degree of freedom, and usually this n minus 1 is denoted with the notation small letter v. So we have critical region or the rejection region. The region between the critical region, we call it as the acceptance region. That is, in this white shaded region is the acceptance region. This light blue color shaded region is the rejection region. Similarly, in the remaining two cases, the first case is sigma square less than sigma naught square. We call that as a lower or left tail test, and the second case is sigma square greater than sigma naught square. We call it as upper tail test. We have this graph is corresponding to sigma square less than sigma naught square. That's a lower tail. In the left side part, we'll have a rejection region, and corresponding to sigma square greater than sigma naught square, we'll have the rejection region in the right side part. So in the two-tailed test, entire area rejection area will be divided into two part, left side and right part. But in single tail, that is left and right tail test, entire area will be in only one side, that is either in the left side or in the right side. So we have here corresponding critical region and acceptance region. Now let us discuss this theory with a problem here. Let us consider this problem. An automated filling machine is used to fill bottles with liquid detergent. A random sample of 20 bottles results in a sample variance of fill volume of 0.0153 fluid ounce square. If the variance of fill volume exceeds 0.01 fluid ounce square, an unacceptable portion of the bottles will be either underfilled or overfilled. Is there evidence in the sample data to suggest that the manufacturer has a problem with underfilled or overfilled bottles? Use 5% level of significance. So this is the problem we are given here. Let us consider the given things in the problem. First, it is given that we are considering sample of size 20, that means n value is 20, and sample variance is listed as 0.0153, and it is expected that population variance must be 0.01. So let us consider the hypothesis we are going to discuss. This one is null hypothesis. That is the equality of the variance here. That will be sigma square is equal to 0.01. And the alternate hypothesis, here the problem is with the variance being more. If variance is less, we don't have a problem. Variance exceeds 0.01, then there is a problem. That is sigma square greater than 0.01 will be a problem. And as it is, you can see that there's only one tile that is at the right side, means it is a right tailed chi-square test. We are applying right tail chi-square test, and it is again given that alpha is 0.05. Corresponding to that, let us determine the rejection region. Here rejection region will be chi naught square less than or equal to chi square 0.05, because it's one-sided, entire thing will be on the one side. Right side there will be a rejection region, that's why below this value will be a acceptance region. And 19 comes from the number of samples. Sample is 20, so n minus 1 is the degree of freedom, that is 19 here. We determine this value from the chi-square distribution table. Let us consider the chi-square distribution table. Corresponding to alpha is 0.05, and corresponding degree of freedom is alpha is 0.05, degree of freedom is 19, and the corresponding value chi-square value is 30.144. So we have the corresponding chi-square value, that is 30.144. Let us, from the given data, let us determine the chi naught square value using the test statistic formula, that is n minus 1 into s square by sigma naught square. And if we substitute and simplify, we will get chi naught square value as 29.07. Now with this chi naught square value, we can observe that chi naught square is less than the critical point here, that is 30.144. So it is in the acceptance region. We can, from this we come to a conclusion that we are not in a position to reject the null hypothesis. That is, do not reject null hypothesis. That is, this given data is inconclusive to make a statement that the manufacturer has a problem with overfill or underfill bottles. So one problem. Let us take one more problem. A maker of a certain brand of low-fat cereal bar claims that the average saturated fat content is 0.5 grams with standard deviation of 0.2 grams. In a random sample of 8 cereal bars of this brand, the saturated fat content was observed as given. Would you agree with the claim on standard deviation at 0.5% level of significance? It is given that 8 samples are considered, and manufacturer claims the standard deviation of the population is 0.2. So as usually we will use variance. So variance of the population is 0.04. Now as we need in this test variance of the sample, we have calculated the mean of the sample, that is x bar, we got it as 0.475, and also we calculated variance of the sample, that is 0.0276. Now let us go for the solving problem step by step. Let us consider the null hypothesis first. Here, null hypothesis sigma square is equal to sigma naught square. Sigma naught square is 0.04, and the alternate hypothesis is again with respect to 0.04 only. Here his claim is standard deviation is 0.2. That means his claim will be wrong in if standard deviation less than 0.2 or if standard deviation is greater than 0.2. So here alternate hypothesis will be sigma square not equal to 0.04. So from this we can observe here we are going to apply two-tailed test, two-tailed chi-square test. We are applying two-tailed chi-square test. Also, it is given that level of significance alpha is 0.05, and let us observe the acceptance region. As it's a two-tailed test, the entire area alpha will be divided into two parts. Each part will be containing area of alpha by 2. So left side critical point will be chi-square 0.975, 7 is the degree of freedom, that is n minus 1, and n is here 8. Now we determine this value from the table. We want chi-square value for 0.975. So we have 0.975 and degree of freedom is 7, and the corresponding value chi-square value is 1.69. So left side critical value is 1.69. Similarly, right side corresponding value we want, that is for 0.025. Alpha is 0.025 and degree of freedom is 7. Corresponding chi-square value is 16.013. So upper critical value is 16.013. Now again let's determine the test statistics chi-naught square, that we will get it as 4.83. And again we can observe here chi-naught square value will lie between 1.69 and 16.013. That means the chi-naught square value is in the acceptance region, so you cannot reject the null hypothesis. That means do not reject null hypothesis. Do not reject null hypothesis. That means from the given data we cannot conclude that the maker's claim is wrong.